Good day, grade 8 learners. I am Mom Cherry, your science teacher, and welcome once again to Science 8. I hope that you are doing okay and safe in these trying times. Let us once again enjoy this week's lesson as we venture to the world of chemistry in this third quarter. For today's lesson, you are expected to explain the properties of solids, liquids, and gases based on the particle nature of matter. Specifically, you will learn to distinguish matter from non-matter, describe the common properties of matter, and discuss the composition of matter. Before we start our lesson, here are some reminders for you. First, have your pen and activity notebook with you. Listen attentively and write down the important details and question if there's any. Remember that you can pause and replay this video for clarification and enjoy while learning. Last quarter, you have learned about Earth and space, and you have learned that there are many objects that are essential to us in our planet, Earth. Now, let us try to distinguish some objects if it is matter or non-matter. You will write M on your activity notebook if it is matter and N if it is non-matter. Are you ready? The first object is rock. Is it matter or non-matter? The answer is M, matter. Next one, water. Is it matter or non-matter? Yes, you're right again. Water is matter. How about this next object? Heat. Is it matter or non-matter? The answer is N, non-matter. And then, the next one is air inside the balloon. It is matter or non-matter? The answer is matter. And the last one is light. Is it matter or non-matter? Good job! Light is N, non-matter. Now, let's have our activity number 1. Please ask the assistance of your parents in doing this activity. If the materials are not available, you can just watch the video and answer the guide questions. Prepare the following materials and perform the activity. Measuring cup, 1 liter water, 4 clear glasses, two tablespoons of food coloring, tablespoon or barbecue stick, marking pen, 3 ice wrappers, stone that fits into ice wrapper, with the use of measuring cup, place 100 ml of water to 4 clear glasses. If measuring cup is not available, use tablespoon. 1 tablespoon equals to 15 ml. Mark the level of the water in the first glass with a marking pen. Put 2 tablespoons of food color in 1 glass. Leave it undisturbed for 5 minutes. Observe. Then stir the mixture using spoon or barbecue stick. Label it as Mixture A. Answer the guide questions. Number 1. What happened to the food color before the mixture was stirred? Why? Number 2. What happened to the food color after it was thoroughly mixed? Why? And number 3. Did the level of water increase or decrease? What does this show? Take 15 ml or 1 tablespoon from mixture A and mix it in the second glass containing 100 ml. Label this as Mixture B. Take 15 ml or 1 tablespoon from mixture B and dissolve it in the third glass with water. Label this as Mixture C. Take 15 ml or 1 tablespoon from mixture C and dissolve it in the fourth glass with water. Label this as Mixture D. Guide questions. How do you describe the mixtures in the 4 glasses in terms of volume and color? Explain your answer. Prepare 3 ice wrappers. Place a stone in the first wrapper, water in second, and air in the third. Tie each wrapper. Press each wrapper with your finger. Guide question. What did you feel? Untie the ice wrapper 1 containing the stone and pour or empty it. Guide question. What have you noticed? Are there parts of the stone left in the container? Why? Next, untie the one containing water and pour or empty it. Guide question. What have you observed? Is there water left in the plastic? Why? Lastly, untie the ice wrapper with air. Guide questions. What have you observed? What happened to the particles of air after the plastic was opened? Why? And lastly, based on the activity, explain how solid, stone, liquid, water, and gas, air behave. So based on the activity, what have you learned? Can you define matter? Well, when we say matter, it is anything that has mass and can occupy space. The mass and the space that the matter occupied are the fundamental characteristics that describe matter. When we say mass, that is the amount of substance present in the object, while the volume is the measure of the space occupied by an object. Thus, we can say that matter is anything that has mass and has volume. That is why rock, water, and air inside the balloon are matter, because they have mass and can occupy space, while the heat, light, and other forms of energy are non-matter because they do not have mass and cannot occupy space. Matter can be described using its characteristics. These characteristics are known as properties of matter. Properties of matter can be classified into two: physical properties and chemical properties. Physical properties are those characteristics of matter that can be measured and observed without changing the composition of matter. There are different types of physical properties of matter. The first one is the mass. When we say mass, that is the amount of substance present in an object. Next is volume. That is the measure of space occupied by an object. Density, mass of a substance per unit volume. Next is a state, the form in which matter exists. It can be solid, liquid, or gas. The next type is melting point, the temperature in which solid becomes liquid. Another is boiling point, the temperature in which a liquid becomes a gas. Remember that boiling and melting vary depending on the type of a substance. Example, mercury has a different boiling point compared to water. Another, iron has different melting point compared to silver. The next type is freezing point, the temperature when liquid becomes solid. And condensation point, the temperature in which gas becomes liquid. The next property is color, the characteristics of matter with respect to light reflected by an object. Odor, the smell or non-smell of matter. Clarity, the ability of light to pass through the matter. Luster, the ability to reflect light. Form, the structure in the matter. Texture, describing the surface of matter. Brittleness, the ability to break or shatter easily. Thermal conductivity, the ability to transfer thermal energy or heat to something else. Electrical conductivity, the ability to conduct electricity, in which the atoms allow their electron to move or flow. Viscosity, the ability of matter to flow. Hardness, the ability to resist scratching. Malleability, the ability to be pounded into thin sheets. Ductility, the ability of matter to be drawn into thin wires. Examples are tungsten and platinum. Solubility, the ability for one substance to be dissolved into another substance. So those are the different types of physical properties of matter. Now that we learned the different types of physical properties of matter, let's define what is chemical property. Chemical properties are the characteristic of matter that can be identified by changing the composition of matter through chemical change or chemical reaction. Example of chemical properties are flammability and reduction and oxidation. Flammability or ability of material to ignite or to cause a fire or combustion. Examples are LPG and methane. While reduction and oxidation is change in the chemical substance due to gaining or losing electron. Even though all matter have mass and volume, different samples of matter can also have different properties. Now that we can describe matter based on its properties, it is also important to know what matter is made of. studying about matter involves dealing with very small particles beyond an ice-cream.
So, what is matter made of?
2005 years ago, Asian philosophers such as Leucippus and his disciple Democritus presented the idea of composition of matter. According to Leucippus, a philosopher who first proposed the idea of an atom, he believed that all things are made up of tiny, indivisible particles. So when we say indivisible, it means it cannot be divided. While Democritus, a student of Leucippus, also thought the same way. He posited that all matter was composed of small, indestructible particles, which he called atoms, from the Greek word atomos, which means indivisible. Aristotle strongly opposed to the theory that atoms were indivisible. He believed that all things can be divided infinitely. Therefore, he said that there was no smallest part of matter. He also claimed that all matter consisted of 4 elements, and that 4 elements includes air, water, earth, and fire. Because during that time, Aristotle was more popular and influential, so that is why during that time, many people accepted this idea. The idea of composition of matter was not further explored and studied until John Dalton in 1800 presented concrete evidence that all matter is made up of very small particles called atoms. Today, we learned that atom is the smallest particle of an element that has all the properties of the element, the building blocks of matter, and it is divisible and can be divided as it consists of smaller particles called subatomic particles. While molecule, it is a particle consisting of 2 or more atoms combined together in a specific arrangement. Examples are water, in which 2 hydrogen atoms were combined with 1 oxygen atom. The same thing with oxygen, in which 1 oxygen atom and 1 oxygen atom combine together to form oxygen. Now let us try to look what is inside the matter, what is inside the solid, liquid, or gas. We have here 3 pictures or 3 figures of the particle model of the 3 states of matter: solid, liquid, and gas. The first one is solid. Solid particles are packed closely together in fixed position. As you can see, the particles can vibrate but cannot move around. The particles of solids are held together by strong forces of attraction. Just like, for example, in our activity, the rock inside the ice wrapper. So the solid particles of rock are held together and they cannot move. Generally, solids have definite shape and volume, just like the rock inside the ice wrapper in our activity. The next one is liquid. Liquid particles are close to one another but with spaces between them. The particles move and change position, but not as free as in gas. The particles are held together by forces of attraction, but not as strong as that of solids. And they are generally have definite volume, but no definite shape. So that is why When you pour water into a glass or into a jar, it will follow the shape of the container. The last state of matter is gas. Gases consist of particles that can move constantly and freely in all directions because they are far apart and the attraction between them is negligible. Thus, gases have neither definite shape nor volume. The following are ideas about the particle nature of matter. Number 1. Matter is composed of a large number of very tiny particles. The particles are constantly moving in any direction. And there are spaces between the particles of matter. And last one, there are forces of attraction between particles.
From the materials we use in Activity 1, can you describe the following matter based on their physical properties? 1 glass, 2 water, 3 air, 4 rock, and 5 red food coloring. Please answer these on your activity notebook. Now let's see what have you learned. If you have any questions, please feel free to ask me through text, messenger, or call. You can also write your questions through Dropbox.
For our last activity, let us have the finger activity. So put the finger down if you think the following statement describes you. So put your finger down if you have mass. Put your finger down if you can occupy space. Put your finger down if you have density. Put your finger down if your body can perform chemical processes like metabolism and cellular respiration. And lastly, put your finger down if your body is combined of tiny particles. Good job! If your 5 fingers were put down, congratulations, because you are an example of a matter. Grade 8 learners, if sometimes you are down, remember, you matter. Thank you so much for listening.